Solving logarithmic equations. We'll look at an example where there's more than one log in the equation. Now, we know that if you do e to the ln of something, it's just equal to that something. E to the ln of x is equal to x. So you might be very tempted to put e as the base of all of these things, so that the ln's cancel away. Unfortunately, this is not algebraically correct. And so if you wanted to do e as the base of things here, it would have to do e as the base of both sides. So this would be correct. You could put e as the base of both sides of this whole thing. So the idea is that if the left-hand side equals the right-hand side, if e is the base of both sides and the exponents are the same, then both sides are equal to each other. Unfortunately, if you do this, you cannot just distribute this exponent of ln of 2 to the e and the exponent of ln of x minus 2 to the e to get what we had in the previous line because of how they're separated by minuses. This would have to be a times in order for you to go about doing some kind of distribution here. So how do we get around this? What we're going to do is we're going to use log properties to first combine any logs. If you see multiple logs on one side, combine them using log properties first. So by that I mean on the right, I can combine ln of 2 minus ln of x minus 2 into ln of 2 divided by x minus 2. And that is via the log property that says that if you have ln of m minus ln of m, that's equal to ln of m divided by n. That's one of our log properties. Now that you just have a single log on either side, so you have one log on the left and one log on the right, you can put e as the base of both of these. And this is algebraically correct. And you can then cancel these away. So these will cancel away. Whereas before, up here, these would not cancel away because of the minus sign. It gets in the way. So if you have a single log, you don't have to worry about that. So we can simplify this into x equals 2 over x minus 2. So general strategy. Take the equation you start with. If there's more than one log, combine them into a single log on either side. Then get rid of the log using what we've learned. At this point, we can try to solve for x. Now, I don't like having x's in the denominator of fractions, so what I would do is I would cross multiply here. This is like on the left, it's like x over 1. So if we cross multiply, we get x times x minus 2 equals 2 times 1. And if we multiply out here, we get x squared minus 2x equals 2. And from here, you have to try to think about how to solve this equation. So how do you solve this equation? You should identify the type. So it's not a linear equation, but it is a quadratic equation. I know that it's a quadratic equation because I see this x squared term, this linear term, and this constant term. Now, quadratic equations, we always want to solve them by getting everything on one side and having it equal to 0. So I'm going to subtract both sides, 2 from both sides to get x squared minus 2x minus 2 equals 0. And this is how we solve quadratic equations. Get everything on one side and have it equal to 0. In other words, put it in ax squared plus bx plus c equals 0 form. From here, we have two techniques. We can either factor this or use the quadratic formula. Now, if you try to factor this, you're going to get stuck. It doesn't factor. So we're going to use quadratic formula. So quadratic formula says the solutions to this are x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we need to identify a, b, and c and then plug them into this formula. So first of all, notice that a is 1, even though it's not written there. So we have a is 1, b is negative 2, and c is equal to negative 2. And I'm going to plug all of these into our quadratic formula. So x will be equal to -2 plus or minus the square root of -2 squared minus 4 times 1 times -2 all over 2a, so 2 times 1. From here, I'm going to go through and simplify this as much as I can. So this is going to be equal to 2 plus or minus the square root of 4 plus 8, or, well, let's just write it 4 plus 8 all over 2. And so this becomes 2 plus or minus the square root of 12 over 2. Now 12 you can write as 4 times 3. And that's useful because I can pull something out of that radical. So this is 2 plus or minus the square root of 4 times 3 over 2. And if you have inside of a radical something times something, you can split them into their own separate radicals. So I can write this as square root of 4 times square root of 3. That's something you can do over multiplication and division, but not addition and subtraction. Square root of 4 is 2, so we'll simplify that. And then it looks like you can do a little bit of canceling here. So if you want to be 100% certain, what you should do is factor. So on the top, we can factor out a 2. And if you can factor and then cancel, then the canceling is okay. But if you can't factor and then cancel, then it's not. Okay, so x is equal to 1 plus or minus root 3. Now, this is two answers. X equals 1 plus square root of 3, and x equals 1 minus square root of 3. Now you want to be very careful when you solve these log equations, because sometimes when you get to the end, one of your answers won't actually be in the domain of the original equation. And so you won't actually count it as an answer. Let's go back up to our equation and make sure that these are both answers, or just like check and see if they are. Our original equation was this. I'm going to cut and paste it down below so we can check it out. Okay, so this was our original equation. Now we want to see if we can plug both of these in. So this one right here, 1 plus square root of 3 is a positive number. And we just want to make sure that when we put it into this x spot and then this x minus 2 spot, we don't get something that's not in the domain of ln. The domain of ln is, you have to only plug in positive things. So what we're looking for is, when you plug in this number, do you get a positive thing in here? Do you get a positive thing in here? And when you plug in 1 plus square root of 3, you do get a positive here, and you do get a positive here. So this is an okay answer. But when you look at the second answer, 1 minus square root of 3, this is actually negative. And so type in your calculator, you're going to get a negative. And if you try to stick it in here, ln, when you take it, ln of 1 minus square root of 3 is undefined, because you cannot do ln of a negative number. So this second answer, we're not going to count it as an answer because it's not in the domain of the original equation. So our only answer here is x equals 1 plus square root of 3.